Xinxin Harbor Village, a small fishing village, is located in North Hainan province of China. As for economic locations, Chaotou City is a nearby commercial center. Xinxin Harbor Village and other villages mainly concentrate on agricultural and fishery production. Xinxin Harbor Village has expressive and rich coastline landscape. Therefore, life cycle of villagers is highly connected with the everyday tidal change. The developed mob of this village is another feature. As family members increased, houses were constructed vertically to the coastline. Currently, as we can see, rows of east-west direction houses are blood-tie relatives. The relationship and feelings of kinship is connected by open spaces, such as empty spaces in between houses and cooperatives. However, a severe typhoon in 2014 revealed the simplicity and crudeness of the infrastructure, industry, and living system in Xinxin Harbor Village. First, we recorded the current systems on the site and drew out the operation diagram. Through adding facilities and reinforcing characteristics of Xinxin Harbor Village, we diversified the village system and increased the tenacity of the village to have more alternatives when facing different conditions. We divide our design into 5 systems. Cooperative is the key of industrial system. Different industries has their own cooperatives, and according to the industry distribution, the village could be seen as 4 zones. We organized cooperatives and clarified their identity. At last, the products will be gathered to the new established reefer and transfer station in the new community. The new established stratified road system will link the place of production, co-op, and old road system through paraground. Fresh agriculture and aquaculture products could be delivered more efficiently to markets. The newly inserted technical school then integrated the reefer, co-op, and auction plaza, gathering talented people to the village for future training and research. We use sewage collection and disposal system combined with mangrove cultivation to create a natural nutrient circulation system. First, we organized the original sewages. We connected them to the new established sewage disposal tank and then linked the reclaimed water to the coastline mangrove belt. We moved the interspersed livestock to the mangrove belt and reused the reclaimed water to feed the animals and cultivate the mangroves. The feces created by livestock are metabolized by mangroves and drained into the ocean, feeding the oyster and farm fish. Furthermore, the waste sludge in the sewage collection tank, as well as oyster shells, all could be used as fertilizer to cultivate farmland. Nevertheless, the oyster shell could be used as building material and disaster preventing. We use tidal energy as the alternative power. Inspired by the original net cage aquaculture, we use ship hub and net fishing foundation as combination to design hydro energy boathouse. Took the average 2-meter high tide level as an opportunity to generate power, and supported the original fossil fuel used in the village. The surplus electricity could be stored as mobile battery and bring back to the village. Following the original housing pattern and harmonizing with new community systems and facilities, new lifestyle formed. After the establishment of the stratified paraground system, we studied the relationship between paraground and old building, and created new housing following similar building logic. The new AC housings will still follow the east-west direction, which is vertical to the seashore. We kept the ground level for industry and public usage. Simultaneously, the between houses spaces would be raised to the height of paraground. The new constructions of previous 4 systems were the key resilience when disaster struck. There were 3 steps of disaster preventing. First, the small islands formed by oyster shells demolished the force of the wave. Second, the seashore mangroves and oyster shell cage would also reduce the power of waves and delay the time which the flood went into the village. Third, on land, villagers withdrew through the co-ops to the paraground and moved fast to the transport station, finishing the evacuation. 5 systems would be separated into 4 phases. First, the middle axis of sewage collection tank and center industry belt would be established, including the new river and transport station of the harbor. Second, the development will gradually spread into north and south of the site. Third, both the new road network and the mangrove area are connected and completed. The last phase would be the complete of the new community on the east. The mangrove area will gradually spread from original boundary to a flourished ecosystem.